In this recording, we're going to learn how to simplify complex fractions. So I'd like you to give yourself the heading on your notebook paper and then write down these 4 fractions that are called complex fractions. And as you're doing so, I want you to think about this question. What do you notice and what do you wonder about these fractions? I'll give you a moment to write it down. So pause the recording and write those down, please. Okay, so hopefully you wrote down each one of those fractions and you noticed something about each one of them. And maybe you wondered, well, what are we going to do with them? Why do they exist? Well, fractions within fractions occur quite frequently in higher level math that we're going to get into. It happens in trig identities, um, happens in expressions that happen to have variables that have values that are fractions. Okay, so it's going to happen, and our task simply is going to be to get rid of the little fractions so that each of these complex fractions has a little fraction within its numerator and or denominator. Let's define formally what it means to be a complex fraction. Okay? I'd like you to write down this definition. So the definition is a fraction whose numerator and or denominator contains one or more fractions, or possibly a negative exponent, okay, as we had in this last example here. This is a negative exponent. All right, and a negative exponent we're going to learn can be rewritten as a little fraction. Okay, so just as a note, y to the negative second power is equal to 1 over y squared. So if I have a negative exponent, it's going to turn it into a fraction, with the exponent becoming positive in the denominator. Okay, so y to the negative second becomes 1 over y squared. The alternative to a complex fraction is just called a simple fraction, the kind that you've gotten used to, like half and 2/3. So we'll do 4 examples together, and then you'll do one on your own. Okay? So the task is always simplify. We're going to try to simplify this fraction, and the way we're going to do so is we're going to try to get rid of the little denominator. So I'd like you to write down this example, please, and then I'd like you to circle the little denominator. We're always going to approach it this way. That's the thing I'm trying to get rid of, because if that weren't there, it would just be a simple fraction, right? Our technique is this. Multiply all the terms, and here there are 4 terms, right? 1, 2, 3. Sorry, there are 3 terms. Terms are connected by addition or subtraction. So multiply all the terms by the LCD of the little denominator. So we're going to do it this way. State what the LCD is. The LCD is just x. So come in here and multiply by x. And when I'm multiplying x by a fraction, I like to put it over 1. That seems to line things up nicely, so I don't think I'm multiplying it by the denominator. All terms by x. Right? So if I'm multiplying just by a non-fraction, I just put it next to the x. If I'm multiplying it by a fraction, I write x over 1. The cool thing is, those x's divide out. And that was the whole point, right? I wanted my x's to divide out so I wouldn't have any complex fraction. So let's rewrite what's left. Okay, up in the numerator, I've got 8 times x, so I've got an 8x. Here I've got a 1x, and here they all divided out, so I simply have a 1. I don't have nothingness, I just have a 1. So 8x over x plus 1, that cannot be simplified further because I can't factor the denominator. So there's our final answer. It's a simple fraction with no little denominators. In our second example, we have that strange negative exponent there. And what we're going to do anytime we see that term that has a negative exponent is we're going to try to get rid of that little exponent by writing it as a fraction. Okay? So if you have an expression like that, you're going to rewrite y to the negative second power as a little fraction. 1 over y squared. So I just turned this negative exponent into a term with a fraction in the numerator, which makes it a complex fraction, right? All right, so here what we've got is a little fraction, and I want to circle the little denominator here because that's what I'm going to try to get rid of. So my LCD is just that. It's just the y squared. Okay. So what I do is I multiply all terms by that LCD. I come over here and multiply the 3 by the y squared, the 1 by the y squared, the y squared by the y squared, and here, y squared, I'm going to write over 1 because I'm multiplying it by a fraction. Y squared over itself divides out, right? Awesome. That's what I wanted to have happen was divide out, so I wouldn't have any little fractions. Now this doesn't make nothingness. Some students think they just leave that out because it's gone. No, it's a 1, right? 1 over 1 is 1. So I've got a 1 plus 3y squared all over y to the 4th plus y squared. And because I can't factor the numerator, and there's no common factor for the denominator and the numerator, that's our final form. Okay? Slightly more complicated examples in 3 and 4. Give you a chance to write them down. Same technique though. Circle all the little denominators. Why don't you identify what you think is the LCD and then play the recording? Hopefully you said the LCD is XY, right? It's the LCD of what you just circled. So multiply all terms by that LCD. So it's going to be XY over 1. XY, XY, but I'll put it over 1, right? Because I multiply by a fraction. So the point of that is the little x and that x divide out. Just got rid of that denominator. Cool. That y and that y divide out. Got rid of that denominator there. So my form here doesn't have any little denominators. It just has 2 times y, 2y. 6xy all over, well, all I see that's left is just an x. Now I can factor the numerator. I can factor out a y, but there's no y factor in the denominator, so that's our final form. Okay, last example we're going to work out together is a challenging one. So, I'd like you to circle all the little denominators, get as far as you can with it, and then play the recording. Okay, so hopefully you change this into addition of opposites like we talked about back in our subtracting fractions unit. You circled all your little denominators. I'm going to recommend you do that every single time. Let's stay consistent with our technique. Circle all those little guys. And then think about what's the LCD out of all those little d's. Well, it has to have the largest exponent for each variable. Otherwise, it won't be big enough. If you tried to just make it xy, x squared can't go into xy, right? So it's got to be x squared, y squared. So it might help if you have colored pens, colored pencils. We're going to go with x squared y squared over 1. Okay? Same thing, x squared y squared over 1. We're going to put it over 1 when we multiply it by a fraction. X squared y squared over 1. Show that multiplication with your parentheses times each fraction. Okay? This is the fun part, dividing out. Divides out with the x squared, divides out with the y squared. Now let's be precise here. X divides out x squared over x just gives us an x, right? So I'm just crossing out the 2 here. Y squared over y just leaves a y. So let's rewrite what's left. Y squared minus 1 times x squared, so negative x squared. X squared y minus xy squared. Okay. There's our answer, except maybe factorable, maybe simplifiable. Certainly we've gotten rid of the little fractions. That was a good job. But maybe there's some factor we can do. And it turns out there is. It's a y minus x over y plus x, right? Difference of 2 squares. If you try to factor the denominator, there's a GCF, right? xy. So pull out that xy. That would leave us x minus y. Very difficult factoring there. You might be saying, well, there's nothing you can do with that, right? Wait a second. I see opposite binomials. I see y minus x over x minus y. Those divide out to leave a negative 1. So there is our final answer. You can just leave the negative 1 in front if you like, not even have to distribute it. I'm fine with that. At the bottom is xy. Because these are terms in the numerator, they cannot divide out with what's in the denominator. Okay? So I've done 4 examples with you. I want you to do this last one on your own, and then play the recording when you've got it thought out. Okay? So please pause, play the recording only when you have an answer. All right, so hopefully you worked this one out. If not, you better pause it. Do not play this recording until you've got your answer worked out. All right, little denominator, x, 3, and x. That's kind of a sloppy circle. We'll try to redo that circle there on that 3. That came out kind of poorly. All right, x and 3 make an LCD of 3x, right? So we'll identify what our LCD is. It's 3x. Go ahead and multiply all your terms by 3x over 1. Or in the case of just a 1, multiply just by 3x, right? 3x over 1 and a 3x over 1. We divide out any factors that are in common. So that leaves just a 3. That leaves just an x. That leaves just a 3. We change these subtractions to addition of opposites. Top, I've got an x. That's all that didn't divide out. At a negative 3. Here I've got a 3 times 3. That's a 9. Here I've got a negative 3x. I'm looking at this, I'm thinking, this kind of looks like there's a lot of common stuff here, but let's just think about it for a second. The denominator, all that's common is a 3. The numerator, a 3 is not common, so I would not be able to simplify that at all. There's your final answer. Thanks for watching.